Forensic scientists are always surprising us with tremendous amounts of work they must perform every day in order to prove the innocence of people. Analyzing forensic evidence is an extremely important job because it allows them to convict victims. However, there are some cases where there is not enough evidence to convict a person with a crime or prove their innocence. As a result, there are many innocent people who remain in prison, but thanks to forensic scientists, they have designed a new method in order to solve crimes using DNA. This method uses different approaches in order to exonerate, which means to prove the innocence of people who were wrongly convicted. But that's not as simple as you think. It takes time and a lot of effort and hard work in order to reach such conclusions. For example, the first method that scientists used was RFLP, which is restriction fragment length polymorphism. It is a difference in DNA sequence that can be identified with the existence of different size fragments after cutting DNA with an enzyme called endonuclease. However, it is not used today a lot because it requires a very large sample. So what are the steps of RFLP? So first, you extract some DNA from the blood cells. Then you cut the DNA strands into fragments using the restriction enzyme, endonuclease. Then you place your fragments in a box that contains agar gel, and you turn in an electric current to sort the DNA fragments according to the length. And this is known as electrophoresis. Then you put the DNA on a paper, and the DNA will be visible to the naked eye. However, later on, scientists were able to find a more practical method, which is STR, which stands for shorthand and repeats. They favored it over RFLP because it is more accurate than it, and it's able to use a smaller sample, which makes the segments easier to separate and easier to distinguish between. So, STR is used to make copies of short identical DNA sequences, which are arranged in particular regions of chromosomes. It evaluates specific regions in DNA that has repeated bases. So the differences in STR regions help scientists differentiate one DNA profile from another. Another difference between it and between RFLP is that it does not use endonuclease to cut DNA. Instead, it uses PCR, or polymerase chain reaction, which makes copies of small amounts of DNA to create a larger sample to be used in analysis. It is used to identify length of shorthand and repeats, and using this method, the FBI looks at 13 locations on DNA profile. Wait, that's not it. After scientists collect fingerprints, they put it in the CODIS. This is a computer program that aids criminal justice by forming a database to compare DNA profiles that are stored in it. Every state has its own database, which includes a collection of DNA profiles from people who were previously convicted. It's extremely helpful as it allows the FBI to compare DNA profiles on a program that could link people convicted by matching their DNA. The success of CODIS is highly shown by the large number of matches who were linked to actual killers, in addition to many people who were exonerated after its creation. However, there are some concerns with the CODIS because it's revealing personal DNA profiles for other uses other than medical reasons. As a result, it could lead to discrimination with employments or any other future activities. Another problem is the reliability of the sample that the DNA was extracted from. Sometimes the DNA is distorted, leading to false DNA profiles for some people, and again, invading their privacy. But in order to understand the methods that we've talked about today, we need to examine a real criminal case. So, let's take a closer look on Gilbert Alejandro's case. Gilbert was convicted with a sexual assault in County, Texas in 1990. The crime was taking place in the victim's apartment, where she was pulled inside, raped, while her face was covered with a pillow, and she was threatened if she had screamed for help. After the crime took place, she described the victim as Hispanic, 6 feet tall, with a white cap. A couple of months later, Gilbert was arrested. He was wrongly convicted based on some sketch lineups and testimonies, most importantly a testimony by Fred Zane, who said that he has done some DNA testing and the results have shown that Gilbert is guilty. He is given a 12-year sentence. After spending 4 years in jail, the Innocence Project came in place. They performed a re-examination of DNA and the results proved his innocence. Zane was wrong because his report was made before the testing was over, so the new results that have shown his innocence by eliminating the existence of the cell on the victim's clothing. So after hearing Gilbert's story, what do you think of DNA forensics? Do you think it contributed to his exoneration? Well, yes, it did, because the case took place in 1990, so the method that was used was restriction fragment length polymorphism. The scientists re-examined the cells that were on the victim's clothing which showed that his cells were not present. As a result, he was free of conviction. But he has already spent 4 years in prison due to the misleading evidence and the false testimony. How is he going to get back these 4 years? Well, first, Zain, who gave the false testimony, he was fired. In addition, Gilbert was given a payment of $250,000. But is that enough for him? Well, without the new inventions of the forensic scientist, he could have been in prison till now. So special thanks to the forensic scientists who have enabled us to have such new methods in order to save people like Gilbert. So, thanks for watching the Scientific Weekly Report. See you next time.